Um, During the break, I went back to my office and I saw this book, which is your textbook, right? So I just want to tell you my view about this particular textbook. So this is Introduction to Computer Science or Introduction to Programming, the second course. For the first course, I feel using this book as a textbook is a great idea. This book is very good, very solid. I started use this textbook by the same author about maybe 15 or 20 years ago when there's a much earlier version. I use this book. I feel this book is doing a very good job. However, for this particular semester, when you talk about object-oriented programming, I want to tell you that I like to use this book as a reference book, not as a textbook. So my definition about the difference between reference book and textbook is the following. In the textbook, you essentially try to read the textbook to learn the concept. And you're supposed to pretty much know 80% what's being recorded in the textbook. So that's a textbook. You try to follow as much as you can in between the lecture and the book. I mean, for example, the instructor didn't cover a certain topic or didn't cover a good way to cover the topic, then you went for the book. Well, however, the definition of reference book is that, okay, I encounter a problem. I don't know how to represent polymorphism in C++, or I don't know how to do casting in certain way. Then you go to the book to look for information. Okay, so you use it only when you encounter an issue, and you don't in general, unless you're really confused about a whole block of concept, then you go over there to look for the book. And the other reason, which why I don't like to use this book as a required textbook is the following. Is I believe the core concept of object-oriented programming is not being emphasized enough in this and most of the object-oriented programming textbook. In object-oriented programming, sometimes we want to really apply this concept to a pretty good size problem. It's not a very simple problem. Okay, if you look at the example in this book, this is, by the way, not just this particular textbook, but pretty much all the C++ or Java textbook have the same issue. They try to focus on what's the syntax and what's the linguistic perspective about this programming language called C++, and how do you use this particular feature to solve this small problem. That's fine. That's actually for you to understand just pretty much when you learn English or Chinese or whatever language, you need to learn those things. But object-oriented programming has another part, which is the thinking. If you look at the example we are representing, there's no unique way of representing each of the objects. We're basically representing a picture about what's happening. And the thing is that from those picture elements, can we put together to solve a question? And this, in order to learn about this, you have to do this. You have to try to do this yourself. And being challenged with question like this. So my instructional objective is not merely enough for you guys to know how to define an object. That's not my number one instructional objective. My number one instructional objective is for you to have a critical thinking capability, to think about your design, whether your design is mature enough to be able to handle some of the question being asked. Okay, so that you need to have a moderate, a more real world scenario to trigger you to do that. Okay, so you will see that just philosophy about this class. I will gradually do more and more of this and challenge you to think about this. Okay. All right, so now let's actually get back. Okay, let's try to get back about this question. If I want to ask a question, where was this person, when? Okay, when was this person on bus 77? Okay, this is a question, a fair question, right? When did Felix Wu on bus 77 on Monday, April 14th? Okay, do you think this information together will enable you to answer that question, given that you have all this object? Can you do that? Can we do that? I mean, usually I should say, not can you do that? I like to say, can we do that? Plural, because we work together as a team. The class is a team. Okay? Do we have enough information for us to do that? The answer is probably no, right? We have an individual object, but we didn't have information to put all the things together. I mean, I give you 30 seconds to dispute what I just said. Okay, maybe you found, oh, wait a minute, I have a clever way of using all this information to do that, which is a great thing. That worth about the 1 million piece of chocolate, okay? Anyway, probably not, right? So let's actually look at a new, when we think about this, that means we need to have more information. Okay, of course, there are two ways to think about this. I want to answer this question. When was this person on bus 77? I have a two-way to deal with this. One is I actually look at the existing object and try to put in some extra information. That's for example, I can actually put this. I can, inside a person, I can do this, right? Person, I can do, okay, I have things called trace, GPS trace. So this GPS trace to a person is very similar to the bus route. Okay, what is the bus route? Remember? So that's why I think you said this question. This is brilliant. Okay, so I actually have a way to trace where the bus is about their latitude, longitude, and the timestamp. By the way, this shouldn't be LT, it should be LL. Okay, so if I do the trace, now I have the some of the location, right? About this. So I actually make my person object more complicated. So maybe I should have an inheritance, something called traceable person. Okay, that sounds a horrible term. Okay, traceable person. Where's our privacy? By the way, it's great. Okay, traceable person. If the trace is for yourself, only yourself can handle where you have been, then that's actually a great thing, right? You want to record what you have done. Okay, it's about privacy, which I will talk about that later. So I can add a GPS trace about where I am. Does this solve this problem? Okay, now I add this GPS trace to a person via single inheritance. Now I have a traceable person. Let me actually put it down here. I have a traceable person. Traceable person is a person. Single inheritance. Okay. Does that enough to solve the first question? When was a person on bus 77? Does that solve the problem? Probably not, because I know where I am in GPS location, but I don't know whether I'm on bus 77 or not, right? This basically just says I am at this GPS location, but whether I am in the GPS location on the bus, or actually I'm really just near the bus. Did I tell you that in GPS location, there's an arrow, okay? You're on the bus or not on the bus or near the bus, you don't know, right? So that's interesting, but this is not obvious. Even this will solve this problem. So see, the problem become engineering, become really interesting because you need to consider all the situation. Of course, what we can do is that we can use bus route. We can use bus route, and remember bus route also has a GPS route, which is the longitude, latitude, and time stamp. So I can actually say if the bus and the person Felix Fu, their GPS trace, they have exactly the same time, we're exactly at the same location for a period of time. So which means that, I mean, how do I tell whether I'm just happen to be on the same location with a bus, but I'm not on the bus? Because if I'm on the bus, I must move together with a bus. So at least for a short period of time, you will see that my timestamp and my location stamp, they're actually together with the bus, right? So if that's the case, then I can actually derive that the bus route and the person, they're actually on the same route, okay? So that's one way to actually solve the problem. So introduce a concept called GPS trace, okay? By the way, is that any question about what I just said? I'm just saying one of the 10 different possible solutions, but this solution is interesting because we're actually looking at a concept called traceable GPS route. Okay, any other idea? What other ways we can solve the problem? Okay, let me give you another example about how do I solve this particular two question. Okay, let me tell you another solution. And then I want you to compare which solution is better. I declare a new class. Instead of extending the current class, I introduce a new class called record. A record class is basically say, hey, a person and a bus and the time duration. Okay, I declare a new, where is that? This part. Okay, let me use the color to highlight what I'm talking about. So I don't want to introduce GPS, traceable GPS person. I thought that was not necessary, has some privacy concern. So I don't want to have that. So that's why I have this record called person bus time duration, meaning that when you get on the bus, at the time, oh, there is a GPS location as well. Time duration and the GPS location. GPS trace. So what is a record? A record tries to recording a person's relationship with a particular bus, or with a particular airplane, or with a particular boat. So essentially what it does is that at what time this person get on the bus, and then at what location, and then at what time this person get off the bus, at what location. That's called a record. A record from the bus perspective, I try to record my relationship with each of the passengers who get on and off the vehicle. Okay, by the way, this is actually very useful for a lot of applications you can imagine. So I declare a record, which means this record most likely is going to be recorded or owned by the person when you get off, or is by the bus. The bus and all, by the way, the bus also record this relationship. So you have a lots of record in our system. So I declare another object called record. And then this record, obviously, I can answer this question because I just search, okay, the person and the bus was two key. And then I will be able to find out whether this person, the duration is on the bus very explicitly. And also I will know that where was this person at a certain time, which is if it's on the bus, then I will be able to answer based on the record. But if you want to answer in general when the person is not on the bus, then you still want to know its location at a certain time, then you know this traceable person idea. Okay, so depending on the question you want to ask, you see this two questions. When was the person on bus? That's related to record. But where was this particular person at a certain time? That's a general capability. We want to trace the locality about a person. Okay, so this is the alternative solution record. So let me actually tell you we have two solutions. Solution number one, we introduced the concept called GPS route for the bus route. And we also introduced a GPS trace for a person. So we have a class called traceable person. That's the solution number one. Solution number two is actually having a record, which is every time you get on the bus, you get off the bus or get on the plane, get on the taxi, you will be recorded. And then when you get off, you will be recorded. We have two solutions. Okay, let me actually ask you to think about this. Okay, I want you to do this. I'm going to spend the next 1 minute to talk to your neighbor, whoever the student, 2 or 3 students as a group. Let's discuss a little bit which option you prefer and what's their pro and cons. What's the good thing or bad thing about this two approach? Okay, let me actually write down. Traceable person is solution number one, and the record is solution number two. Was my question clear enough about what I want you to do? Okay, go ahead, talk to your neighbor. Okay, now you can talk whatever way you want. And between a traceable person, which solution? I give you 2 minutes, and then I will gather us together to actually listen to your opinion on this. Okay, this is called short discussion. Go ahead, go ahead. Now, if you don't have a neighbor, move around to another neighbor, or I can walk from you. 你懂不懂我在问什么？你在看哈 ，OK。Okay, maybe I didn't explain myself clearly. It's a design choice about how you want to design. So, so this is related to this particular class called, I have a time GPS location person. Yeah, here, you take a look at this. This is a file under the project base called personal time GPS record. If you look at this, it has a identity, has a what I call time location, which is a vector, which is an array, traces. And then let me take a look. Where is a time location? Oh, there is a time location H. Let me see. Where is a time location H? Time location H. It should be somewhere here. Yeah, time location H, which is, if you think about time location, is essentially a GPS location with a timestamp. Okay, so essentially we're being traced to follow. Maybe this is interval. Okay, I don't know how frequently Google report our location to the server. In just assume every 1 minute. Okay, maybe every 30 seconds. So every 30 seconds, our phone is going to find out our current GPS location, and then we will obtain our timestamp. We send this two pieces of information to a particular Google service, so they will be able to track, where we are. Okay, and this is the one way. I mean, this is the pretty standard way about today. You're using iPhone or Android, pretty much you're being recorded in this way. I mean, by the way, either of the solution you're being traced. Okay, in either of the solution you're being traced. It's just tracing a general service or trace as a particular context, like a bus. Okay, so let's actually try to get your help. Okay, get your help. Let's first show hand. Let me get back to my. Oh, not this one. Okay, so let's which way do you prefer or slightly prefer? How about a traceable person? So it means that you're being traced in terms of GPS location. How many of you actually like this solution better? None of you? How many of you actually like the second solution? Okay, a few of you like, can you share with me why you like this better, the second solution? It looks like everybody like this. In fact, I actually like the first one. I'll explain to you why. Why do you think that you like the first one? By the way, there is no right or wrong answer. Just want to hear what's your thinking about this. Why do you hate this? Why do you like this better? Anyone? Well, you. Okay, let me try to help you a little bit. Do you like this because of the privacy concern or because of the computational approach? So computational approach meaning that I can use this representation to solve a problem easier or cleaner, or it's because the design is fundamentally better in terms of protecting users' privacy. Which case is it? Are you thinking about computational perspective or information usage perspective? If you're worried about information usage, such as privacy, please raise your hand. Okay, there is student with private. How about computation? Okay, computation. Okay, I can actually tell you this one, if I want to solve the first question, this is really easy. The computation. I don't have to go through a comparison. So computation, this is really, really good. For the privacy, this is actually pretty good as well. Why is that? Because I potentially can do this. I can potentially turn off all my GPS recording. By the way, by default, our phone is actually reporting our GPS location to some other service. That's a privacy leak. That's important. But I can turn it off. I can actually potentially write a program such that I block the recording from my GPS. Is such as you turn off your GPS location, and then the Google Map won't be able to see you for a period of time. So if I have the capability to control that, which you have, then I can only turn it on whenever I get on the bus. I can turn it on briefly when I get off the bus. So that's the way I can probably do this with a minimal amount of information that being sent to the server. Okay, so that's the consideration. So this is actually a good approach, but not necessarily. This is definitely the only solution, but this is a good solution, very good solution. Some of you actually make the choice. I actually like this solution for a different reason. Okay, I mean, the different reason is because it's a newer way of thinking stuff. Okay, it's a newer way of thinking stuff. So when I think about traceable person, I'm actually thinking, okay, why do I want to give my information to a service like a Google by default? Because today, when you're using this phone, when you're using the service, you already allow another third party to collect your information by default. Meaning that 24/7, even you're sleeping, you go anywhere. I mean, because it's so convenient, right? We have to turn on the service so we can do a lot of things, such as navigation, such as things like that. So, by the way, why do I do the following? I actually turn on my service 24/7, and I have all the information collected as before. But all this information is being kept on my phone. It's never sent to the service. You understand what I'm saying? I actually can have this GPS trace. I have this, I actually collect it, but I never send it out. I actually keep a copy myself. Or I actually keep it in a private place, which is never being used by a free service, such as Google Map or navigation system. And I can still do that, but then I can actually use this information to, the reason I slightly prefer traceable person than the record is that the record, what happened if my relationship is not with a bus? My relationship is not with a bus. Is not with a flight, or is not with a boat, but this relationship is with another person. Okay, for example, I want to know how much time the instructor spend with each of the student individually. So how much time we actually meet together as a group or one-on-one. And that's actually very important because I can trace the time to realize that whether you spend enough time with a particular person. That's actually a very important service today. In fact, today, the only company that's tracking this kind of information, guess what? Which company? That company is called Facebook. Okay, Facebook is tracking how much time you spend, at least in their application, how much time you actually watch the other person's posts. So they will determine what kind of post. I mean, you are wondering why Facebook actually sending this information to you. Facebook is tracking a lot of your information and decide what information is sent to you. But how about those person? I actually never use Facebook. I mean, for example, one of the vacation, I always want to build, but I never have a chance to build. I would probably do later. I'll explain to you why. Is as my own children when they grow up, because I have been really busy. I really want the application to say, hey, whether when they grew up, I actually spend enough time with each of them. By the way, I have 4 kids, so I'm pretty busy. My wife is doing all the work, by the way. So the thing is, I'm really interested is that if I have my phone has my GPS location. My kids, assuming they also have a phone, have a GPS location. And then if this 2 GPS location, they're actually together, close enough, and then the timing duration is the same. Then at least I can actually trace how much time I spend with my family, which is important because when we're busy, we talk about work-life balance. We actually want to remind ourselves that do we spend too much time on assignment or on project or try to do a lot of business and such that we neglect those very precious relationship in our life. And over there, that's why traceable person, I feel it is a very good concept because over here is a person and a bus. But when we talk about traceable person, we can actually look at a person with multiple person or with a single person. Okay, so think about this. It's amazing that when you think about object-oriented, think about this kind of modeling, you actually remind you that what's the interesting information you would like to track, which you want to protect your privacy, and yet you will do something interesting. Okay, so I kind of off the topic a little bit. So for your homework assignment number 2, you're welcome to use either one of the case. And then you can actually develop the third case option that you believe is actually work well. This is called innovation. By the way, I will tell you that number 1 is similar to Google. Number 2 is probably similar to Facebook. And number 3 is maybe your own service you want to create. Okay? All right, so let's actually move on. I'm not going to talk about a little bit more about video recording. I will wait until the next lecture to talk about that. So now I'm going to convert the object that I already designed. If we agree that this set of objects that we actually write down scratch here, they're actually enough for us to solve the problem we want to solve. Then now I just need to do is I want to translate what I described here into C++ classes. And now I can build the whole thing together. Okay. By the way, object-oriented programming, you see that this is a fairly complicated. If I don't go through this exercise, if I give you this paragraph and I want you to write the C++ program, you guys will hate me forever. Okay, you said, wow, my instructor suffered. They gave us a very, very bad example about how to spoil your interest in programming. Okay, I hope I did a little bit to let you hate object-oriented programming a little bit less by going through this. All right, so now let's try to move on to the next step. So now I'm going to do programming. So my first is to look for, no, I want to use the base I gave you earlier. Okay, this is the base that you actually saw on the GitHub. All right, so let's start it with a person. Okay, let's start it with a person. So we already have a person.h. We already declare something called person.h, which the person has only ID like your social security number or citizen number, and you have your name and you have your home address, and that's it. Okay, this is a very simple person. So I'm going to do this. I'm going to use traceable person as example. Is that how do I spell traceable? Let me actually just Google it. I always forgot whether there's an E or not, traceable. Oh, there is an E. Okay, sorry. Move. Okay, I have a file called traceable person. Now let's go back to traceable. Okay, over here, I do traceable person. By the way, any of you familiar with the things I'm doing in terms of this preprocessing line here? You know why for every single .h file, I have this two line, this in fact 3 lines. I put it at the beginning. I always say, if not defined, underscore traceable person H. And then I said define traceable person H. If you look at every single .h file, I have this. And the symbol always match with the file name or the class name. Do you know why I did this? Yes, that's correct. This is trying to avoid you to include the same .h file more than once, okay? Because you see that a lot of files, they include the same file. When you compile, compiler preprocessing is going to put everything together. But if you include the same file twice, the compiler will complain saying that you declare something twice, more than once. So by doing this, if you say, if not defined, then you're going to define. Once you define, when you include the same file the second time, this will fail. This if not defined will fail. Okay, so that's the reason. Okay, and I'm going to do single inheritance. So I only need to include person.h, and I don't need this because person.h already have the rest. And then I'm going to kill this, and then I'm going to do traceable person, public person. Okay, by doing this, I already declare that traceable person is a person, single inheritance. Okay, so basically everything you already declare in person will be inherited by the traceable person. Okay, over here, that's why I don't need these 3 lines. Okay, but I do need traceable person. I need constructor. so far I make it simple such that my constructor looks exactly the same as a person. I mean, this doesn't have to be the case, but I will just start with something simple. And I have a default destructor. And this method I'm going to get rid of. Okay, and then I have a two virtual function, and then I'm going to add something else. And I'm going to add something else here. Okay, so the first step, I just show you a inheritance, a simple inheritance syntax for us to extend the traceable person then such that I have a template for me to start develop the concept of traceable person. Okay, so remember our plan. What's traceable person? I have to have a, let me see, where's my, yeah, Microsoft. So what's a traceable person? It has a name, has occupation. Okay, now you have an occupation. Maybe I will add an occupation at this moment. In the person, I didn't do this. So I have an occupation. I would say string. Okay. And then the important thing is, the most important thing about the traceable person is this part. It's a GPS trace, right? It's a GPS trace. So now let's actually take a look at my other class, whether let me make it a little bit smaller. So this is all the class I have. One of the stuff is a time location.h. Okay, so time location.h seems to be a good thing. It has a location and has a time. So I already have another one, as I mentioned to you, is called personal time. What? I already have this. I'm going to copy the code. I actually declare as a vector. You see that? I actually have a vector. Has identity, location, and that's it. Okay, great. So I already have a class which is a personal time GPS record. And I realized I declare another class called shadow record, which is, I'm not going to talk about shadow record at this moment. So I'm going to use this class, person time GPS record, which I feel is already done all the work I need to do. So I can go to traceable person.h. So I want to use this. So I just say include personal time GPS record h, which I include that. And under here, I basically say, because the class is called personal time record, so I say personal time GPS record. And then I would say, what did we talk about? We call it, what was the name of the attribute? Not this one. Homework 2, yes. Homework 2, I said GPS trace. Okay, let's call that GPS trace. I call it GPS. Let's lowercase. It should be fine. Okay, and over here is constructor. And okay, this is the rest of the function. Okay, I'm happy. Okay, now this is my first version about traceable person. Let's see what we did. A fairly complicated class. If we talk about this, about what is a traceable person, and you will think, oh, there's a lot of complication. But in terms of programming, once you're clear about your object design, it's not that hard. What we did is we have an inheritance from person.h, but we also have another concept where we declare earlier. That's why object programming, you will use a lot of existing class as much as possible. It's called personal time GPS record. I don't know why I choose that, but then maybe I should. Oh, I know why it's a personal time. Why I didn't call it time GPS record is because I want this to be personal. Means this data should not be revealed to other people. This is keep to yourself. So I include this two file. Then I have the inheritance relationship, inherit from person, and I add two new attribute on top of the class person, which I have occupation, which I didn't have in the person. But more importantly, I declare an object called personal time GPS record, which I call GPS trace. And what is personal time GPS record? Is being declared in which is declared in this file in personal GPS record. If we take a look at this, it has only also two attributes. It has an identity, which you want to identify who that person is or whatever identity you want to put in there. And then it's a vector. The key attribute within the personal time record is a vector. By the way, in C++, so vector is equivalent to array. So this is a better interface than array, which I will talk about the syntax. By the way, in C++, maybe I should talk a little bit to just make sure you understand what's going on. So in C++, whenever you see something with a smaller than and greater than this kind of special kind of bracket, that means this is a template. This is something we call template. So essentially, this saying that a vector is an array of which kind of object. So this basically say is a vector of each of the element in the array is a time location object. You can use as an object or you can use as a pointer as well. So you can actually declare, sorry. So just C++ context that this is called a template. I can do this as well. If I do this, that means I declare traces as an array of time, location, object, pointer. Okay, you can declare either way. All right. So in this case, I make it simpler. I actually change it. Sometimes it's or reference. Sometimes it could be reference. Okay. So this is the location. Okay. So I want to just go back before I let you go. So this is what we did today. If you have this, then essentially you have a very solid design to solve for homework assignment number 2. Okay, I will continue this example. I want to show you about the whole path to not just talk about the .h, but also move into the .cpp part, the traceable person.cpp. But as you can tell, you can follow the same principle to apply to the other design. So today, just takeaway is that where's the other one? My homework assignment. Every time I want to look for something is gone. this. Not this one. Where is my file? It's gone. I want to go back to my, did I kill that already? Oh my goodness. Oh, this one, yeah. So we actually went through two different design, traceable person or record. You can actually do a record. You can try to do that to create a record.h. There is a similar file that's actually on the same directory. You can actually follow that. This one, I did this because this was not there. Okay, I will upload whatever we develop in the class to that directory as well. So you can actually see to do object-oriented design is just you need to have experience about how do you translate a very soft description into the object and then into using inheritance relationship to create the class you need. Okay, so I hope you can start thinking about this. This is a very important skill set for you to learn. Okay, I will see you on Monday. All right.